Okay, so this is an example of a problem that's where the numbers are high and where you're almost forced to use prime numbers. So that's what I wanted to show you. This is not quite as big as the problem we did on Monday, but it's still pretty bad, let's face it. And so who could figure out a common denominator? Nobody in their right mind. So what I'm going to do is show you how this could be accomplished. So you take the two denominators. That's all I did was pull out the 66 and the 165, and I'm going to prime factor them. So this is even, so divide by 2, and this is 33. And this adds to 6, so it would divide by 3, and 3 into 33 is 11. So those are the factors, 2 and 3 and 11. Now I'm going to do this one. I can't use 2 because it's not even. I might be able to use 3, so I'm going to add the 1 and 6 is 7. 7 and 5 is 12. So 3 will divide this, and I should just do it right now. So 3 into 16 is 5, 1 left over, and 3 in, this is now 15. 3 into 15 is 5. Now 3 will not go any further, but it seems fairly clear that 5 will go in. So 5 into 55 is 11. I prime factored these so that I could see what was in each of the numbers. And that will help me find the common denominator. So the first number is a 2, a 3, and an 11. That's that one. And this number here is a 3 and a 5 and an 11. Now I can see how to make a common denominator. Remember, the rule is, or at least one way to say it, is you take the most 2s, the most 3s, the most everything, and that's your common denominator. So I see a single 2, so I'm going to have 1 2. There's a 3 here and a 3 here. I don't have any more than 1, so I only need 1. This one has a 5. I've got to take it. And each of them have an 11. And that means I only need 1. So believe it or not, this mess is the lowest common denominator or the least common multiple. And so what I'm going to do is multiply this, and let me see if I actually did it. Maybe not, I didn't. I'm going to go 2 times 5 is 10. 3 times 11, I'm using commutative and associative here. 3 times 11 is 33. So I multiplied my 2 times 5, and this is just a shortcut, so I don't have to do it inch by inch. And then 3 by 11 is 33. So 10 by 33 is 330. That is the smallest common denominator for this stupid problem. So what I'm going to do is I'm going to come back over here and say it's 330. Okay. So here's the part I wanted to show you. 330 was made up of 1 2, 1 3, 1 5, and 1 11. Okay. So if you recall, 66 goes how many times into 330? Well, 66 was a 2 and a 3 and an 11. That was the 66, a 2, a 3, and an 11. That means to get the full 330, we have to supply the missing factor. Now, I could take 66 and divide it into 330, and I would get the number 5, because that's the missing factor. But this makes it easier to just say, okay, I need a 5. And if you don't believe it, you go 66 times 5 is 330. Life is good. 5 times 5 is 25. Now I've got 165. And I'm going to look again at the work I already did. 165 was a 3, a 5, and an 11. So it's this one, and this one. 3, 5, and 11. What's the missing factor? Well, maybe you can kind of judge by looking at these two, but the missing factor is a 2. And if you multiply this by 2 and this by 2, 165 by 2 is 330. You can check it, but it's clearly from this. And 7 times 2 is 14. So what we did was we took this discussing problem, found a common denominator, and now it's pretty simple. 25 and 14 would make 39 over 330. Now that may or may not be the final answer. And what I'm seeing, remember 330 had a 3 in it. And you can see the 3 from here. And this 39 also has a 3 in it. So I'm thinking my best bet is divide both of these by 3. So 3 into 39, 3 into 3 is 1, into 9 is 3. 3 into 330 would be 110. Now, I think that's done, and I'll tell you why. The first thing I notice is 13 is prime. That's a good sign, but it could reduce further if there was a factor of 13 in this. But here was 330. Are there any 13s here? Not a 1, right? There's no 13s. And even if you take the 2 out or the 3 out, there's no 13s. What that tells you is you don't have to sweat this anymore. You know for a fact it's reduced. Now, this problem was difficult. Nevertheless, we could do it, but the real way to do it was with prime numbers. It was not going to work so well without primes, because then you could see into each number, what was this, what was that, what were the different pieces of the number. And so I think I said fairly clearly on Monday that I wasn't going to test this, but I do think there's a lot of good pieces from doing a more difficult problem. When you're forced to use primes, it's a good thing, or basically it allows you to finish the problem, whereas otherwise you'd be up the creek without your paddle, right? Forget that. So what I wanted to do, the material that's coming up next is chapter 4, which is decimals. And so I'm going to start with that. So they're going to play a little about talking about how do you say these numbers in words. So this is 3 and 125 thousandths. So the question is, what is the place value of each? Now this of course was the ones place, but we learned that from before. This first number after the decimal is the 10th with the TH. The second one is hundredth, TH, and the next one is thousands. So if you learned it, if you learn the tenths, the hundreds, the thousands from the other side over here, then the only thing you have to remember is it starts with tenths and hundreds and thousands. So this helps us actually turn this into a decimal if anybody says to do it. This is 3. This is 125 thousandths. So this would be like that. And so they'll play around back and forth with this. And so if the number had just been this much, this would have been 3 and 12 tenths, hundredths, 12 over 100. And if somebody expects you to reduce it, then you do it because you already learned that. But that's definitely what you need to do. Now, there was somewhere in a video that said, be careful about using the word and. And the word and only goes here at the decimal. So this is 3 and 125 thousandths. And there was a mention of this earlier when you had, oops. Okay, 435. So people sometimes say 400 and hear the word 35. No, it's 435 without an and. So this is now 435 and 12 hundredths. So I can only have the word and once. And so I can't be having, because every time I say the word and, it means decimal point. So I can only have it at the decimal point, forget it everywhere else. And so it really depends on who taught you and when they taught you, how well you do with this. And I make a mistake now and then because I was taught to say and all the way through everything. But now I try to pay attention and not do that. And so and belongs here and only here. And so how could they vary this? So they could give you a decimal and ask you to write it in words, or they could give you the words and ask you to write it in decimals. So it's back and forth to make sure you're clear. So here's the end. And so it's 6 and now this is 9 thousandths. So it's tenths, hundredths, thousandths. So in order to put this in, I can't put the 9 here because that's 9 tenths, or here, I can put the 9 here. So that would be 9 in the thousands place. And because this is a decimal, I would need zeros. And so this would then correctly read 6 and 9 thousandths. Yeah, so the next thing we need to look at is this. This is 4 and just 3 tenths. Okay, that's the tenths place and that's the and everything's good. But what if I had this? This technically is 4 and 30 hundredths. Now, which is a better answer if you have them both as a possible answer to put in to the computer? Which is better? And the answer is always the simplest version is the best. Now, in this particular case, 30 over 100 is the same as 3 tenths. And remember how I would do this? Because I could reduce it. So 30 over 100 is really the same as 3 over 10 or 3 tenths. And so this is the better solution. Now, when is this better? If it was dollars, if this was money, then it would make sense to have that zero in place. But otherwise, if it's just a problem that has nothing to do with money, then this probably is your better choice. I doubt if they'll mark you wrong, but they may tell you, round it in some ways. And so that might be an issue. Let's do rounding. Okay, let's try this. So this is tenths, hundredths, thousandths. So let's round to the nearest thousands. TH. Thousandths. That's the only difference between the other side, the whole number side is the TH. So we better get it in there. So if I round to the thousands, which is this one here, the only number I have to look at is the 2. And the 2 is not very big, it's not 5 or more. So this number stays the same. So the answer would be 7596. So it would stop there. So there would be no zeros. There's no need for a 0 here. They wanted 3 decimal places, 1, 2, 3. And so there's nothing after that. Let's try a different one. Let's round to the nearest 10th. So when I round to the 10th, it's this place. And sometimes I mark it off like that, which is basically saying after this number, I won't see anything. And so the only decision here is, does the 5 stay 5 or does the 5 go to 6? The decision is not anywhere but the 9. The 9 is large, it's 5 or more. So this goes up. So the answer would have to be 5 point, whoops, 6. Okay. So I don't know, this is not standard. This is something I just do myself. But it's not a bad idea, basically reminding me that there's, after this line, I've got nothing. There'll be nothing left, especially on decimals. Okay. All righty. So I think you can, I think that should probably be okay. But I want to remind you of something I said. Let's see. No, I don't want to start that way. To add or subtract, do you remember this? You must have like things. How does this apply to decimals? Well, let's look at something. Here's 5 and here's a 0.13. I can't add the 5 to the 1. I can't add the 5 to the 3 because they're not like. And so the first question is, where is a decimal on a number that doesn't have one? And the answer is, it's always here. And I don't know if you remember this, and this may be an age-related thing, but they used to have little spelling quizzes, and they'd say, number your paper from 1 to 10. And so you were taught to do this, like that. Did anybody remember doing that? Yeah. And so at first, before you knew mathematics, you'd say, oh, that's a nice decoration. What is that point there? The point there is the real decimal point. And so if you've ever seen something like this was telling you which side the decimal goes, because some people switch things by mistake. So the decimal point belongs here on a number that didn't have it. So I'm going to put it in. And this other number, and again, I'm writing things vertically because it seems to work the best. It's possible to add the 2 zeros because that doesn't change 5. And it does line things up. And so let's say, and I made it a simple problem, obviously, but trying to make the point, the decimals line up, the whole numbers, the tenths line up, the hundredths line up. You must have like things or you can't be adding. And so that's the trick with this, is to make sure everything lines up properly so that you're adding like things to like things, the decimal points line, everything lines up. And on checkbook statements, I don't know if they still do this. So they would have you write a number in, and sometimes they would put a line here. They wanted you to have the cents over here and the dollars over here. They were trying to tell you where on earth the decimal point was. And they wanted you to keep things lined up if you're going to actually add them. You know what I'm saying? So you add or you subtract. And so that's what that's about. And so it's pretty simple. Let's see. So I don't, whether you put in those extra zeros, let me just whether you add zeros or not doesn't matter as long as you're neat and tidy about keeping things organized. Okay, so as long as things are lined up, it's good, and it won't matter if this is adding or subtracting. It's the same story. Is that okay? So let's just do something quick with subtraction because it probably doesn't matter. The only problem here is there's no decimal point, but I hope I made the point that if there's no decimal point, it belongs on the right side. And so this is 5 point, and this is subtract 0.37. Now here's a case where adding the zeros, I think, makes sense. And honestly, the way I wrote this problem, I would think of it as money. So it's $15 subtract 37 cents. And so I think having the zeros there so I can borrow, this is a 3, there's another borrow. However you do these, there's another borrow. So that's 14.63 or 14 63/100. How's that? Okay. Did anybody work on any of these and have run into problems? Oh, look at what they did. Oh my goodness. Guess what they did? They don't want you ever to forget order of operation, ever, right? And so they'll slip a few of these in, even though we're doing decimals. And so clearly what you need to do is do what's in parentheses first. And so I have a tendency to write some of the scratch work on the side somewhere, but it sort of keeps my problem clean. Let me bring it so you can see it. So that's lined up. This is a 6. This is 6. So what it was in parentheses was 6.6 or 6 6/10 at this point in time. This became that. I copied the parentheses, but the truth of the matter is I didn't have to. And so what I'm down to now is this subtracting. And so 7.8 subtract 6.6. Okay. And I'm getting 1.2 or 1 2/10. So they're just going to keep at you. They just don't want you to forget that. It's so fundamental. And, you know, for this particular course, I think you're better off to not use calculators too much, so that you recognize errors when things happen. I think you have a better sense of how to keep control of a problem without a calculator. There was a time when people were given calculators when they were really, really, really young. And those students had the worst time because they couldn't see an error to save their life. Because they were just used to press, 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 press. And they didn't, and see, order of operation, if you type this in, 7.8 minus 4.3 plus 2.3, it will not get you the right answer because both of these are subtracted. And so without the parentheses and the knowledge of order of operation, even the silly calculator can't get it right. And so you have to have some control of this. So anyway, my recommendation is to do as much by hand. I know I can't completely control it. And honestly, when I'm tired, I just pull out my calculator to keep my checkbook balanced. But the truth is, there's an advantage to doing things by hand. And so I think it sticks with you better. So what I'm going to do now, remember the second part of that rule. If you want to add or subtract, you must have like things. And what that means is you must line up your decimals perfectly. Add zeros if you need to. But remember the rest part of the rule? You can multiply or divide. I'm just going to abbreviate anything by anything. Go for it. Okay? Anything. And so this creeps into not just fractions, not just decimals. It creeps into algebra and all kinds of things. And so it's so fundamental. It's like, oh, I better pay attention to this. So with multiply and divide, here's an example of something, an add problem and a multiply problem or divide problem. In an add problem, if I had 3 pens and 4 pens, and I'm doing this simple because I want to make the point. These are like things, and so I could add them like that. It's 7 pens. And we had the same thing with 3 feet and 4 feet. Remember when we did perimeter? And that would be 7 feet. So that's requiring you to have the same type of thing. But let me think about cars. Miles per hour. The word per between two numbers means divide. So literally, as a fraction, it's miles divided by hours. Now, are these the same thing? Not at all. Miles is distance, hours is time, totally different. And yet, can you do the calculation of miles per hour? Of course you can. This is what I'm trying to say, that when you multiply or divide, whatever, I'm a little bit generous, but that's the idea. But adding and subtracting, you must have the like things. We'll see that as we proceed. So we're into multiplying, and that's the next section. This is 4.3. And so I'm going to multiply 5.6 times 0.2. We'll put a little multiplication symbol here. So what you'll do, I tend to put the larger number on top just because it looks better, but it's not necessary. 2 times 6 is 12, carry a 1. 2 times 5 is 10, and 1 is 11. Now, this is multiply, and so the decimal doesn't come down. You basically count. I've got 1 here and 1 here. I've got to go over 2. So the answer is 1 12 hundredths, 1.12. And so although these had the same number of decimal points, when I went to give the final answer, I had all my numbers right. I needed to move it over 2 places left to get the decimal correctly. 1.9 times 0.26. Okay. So this is going to be a multiply. I'm just going to do it like that, or they would say multiply. Okay. So 9 times 6 is 54, carrier 5. 6 times 1 is 6, and 5 looks like 11. Now I'm going to do the 2. 2 times 9 is 8. Carry a 1. 2 times 1 is 2, and 1 is 3. So notice, I know the book did zeros and stuff. I just shift over one place for the second one. I think it amounts to the same thing. So I'm going to put the 4 down, and this is the 9, and this is the 4. Well, that answer won't work, but what I'm going to do is count my decimal places from the problem and see there's 1 here, and there's 2 here, for a total of 3. So I've got to move this over 1, 2, 3. Now, again, when you're in school, this was considered a perfectly good answer. But when this country decided to work with metrics, this was when the 0 came in. And so most people were taught to use that front 0. I've been told by students that work in hospitals that this is a major error not to put it in. In fact, the hospital can be fined because it's like this, you're thinking, what was the number over here? Could it have been like 1 or 5 or something? When you put the 0 in, it's a definite number for what's over here. And so this is perceived as more accurate and safer in a hospital setting for like medicines and stuff. And so this is now standard. Okay, but the front 0, this is what I call it, and I sometimes call it the decoration 0. This front 0 came in when they started to introduce metrics in this country, which was somewhere around 1975, which could predate some of you for easily. So, but anyway, that's now standard, and so you should attempt to do it. I've also heard from students taking classes in science like chemistry that they lost a point every time they didn't put it in. And that person had lost a ton of points, and they learned their lesson fairly quickly, that was now standard, and the instructor wanted it put in. So I would say put it in. Do I sometimes not? It has to do with my training. If I'm too tired or something, or not paying attention. How is that? So the point I want to make is that the multiplication was 19 times 26. There was no difference in that. 494. The only difference is the placement of the decimal. And so it was 1, 2, 3. And so they go on and on about how to do that. The truth of the matter is that's it. Now, I see some lovely problems. See, these are lovely to me. You don't have to love them. 45 times 100. So the decimal is here, if somebody should ask, on 45. And so when you multiply by 100, you don't have to make it a big, long multiplication problem. The answer is 45 with 2 zeros. Okay. Now, let's turn this into a decimal problem. So you probably realize that this works for anything that's a multiple of 10. If you have 3 times 1,000, the answer would be 3,000. Right? So what about I do this? What if I have a decimal number and I'm going to multiply by 10 or 100 or 1,000? You don't want to do this the long way. You want to do this the short way. And so multiplying by 10 will actually move the decimal 1 place. And because it's multiplication, it moves it 1 place to the right to make the number larger. So is this 15 Is this 15 with a decimal point? Is this 15 with a decimal point and a 0 or 2? As far as I'm concerned, the simplest is the best. And the people that write the programs are thinking the same way that I'm thinking. Is this wrong? No. Is this wrong? No. This is the best. And so 15 without a decimal point, unless it was money and there was something, some reason to, add the zeros, that's best to not. So let's do 4.5 times 100. Okay. When you see multiply by 100, you say, oh, great, because that means you don't have to sweat it. And so you know what I'm going to do. Here's 4.5. 100 amounts to 2 decimal places, and it's multiplying. So you're going to make the number larger. So you're going to go to the right. So I'm going to have to go 1, 2, and I'm going to have to add a 0. So that's 450. So 1 to get around the 5 and another 1 because it's 100 to get it. And so it's 450. Isn't this much easier? So 0.23 times 1,000. 1,000, 1, 2, 3 is going to be 3 decimal place shift, and it's going to multiplying by 1,000 makes the number larger. So you have to go to the right. So here we are. 1, 2, 3. So my answer is 230. And that front 0 now didn't matter because this is a whole number. And so the answer is 230. Any question about that? Oh, here's a cute one. Let's try this one. 5 times 0.006. Okay. Well, I could, I suppose, write it vertically. Although I'm not sure it's necessary. The real computation is 5 times 6 is 30. I don't know if that's real or not. But what we need to do is shift the decimal. So this is 1, 2, 3. And what are we doing? It's 3 that way. And so 1, 2, 3. So what I'm seeing is 0.030 so far. I'm going to add the front 0 because I'm trying to be a good person. And I'm going to take off this last 0, not that one, because that one is making the 3 into the hundredths place, but I can take this one off. And I call it trailing zeros. I've heard that before. It's like 0, 0, 0 after the decimal point. I don't really need them, but I do need this 0, and this is because this is now standard. So I would write this, that would be my final answer in the best form. Any question about that? So how are we doing? So just quickly review, when you see 1,000, you realize you don't have to make a project out of it. 1,000 or 100 or 10,000 or anything along that line. You just have to count the zeros and move the decimal. So that's what we're doing there. So this is 1, this is 2, and you had to go 1 more. So it's 4,090. You can put in a decimal. I noticed in XYZ, at least on your paper, whether they expect you to use a comma here. the problem with commas, does anybody know the reason? In certain countries, the comma is used instead of a decimal point. So if a company is doing business overseas and they see that the price, like this. So this is Great Britain, £1 25 pence. This comma is used where our decimal would have been. And so this is one of the reasons they've sometimes encourage you not to use commas, so that there won't be this confusion between different countries using different symbols. But so far there seem to be using that. This was a metric thing. Instead of a comma, they would sort of make a little space in there so you could clearly see it's 4,090. And so at the moment, I think either one would be acceptable, but I want you to be aware. And my husband was buying things from Scotland. He was playing bagpipes and he was buying things from Scotland, comma, where the decimal point was. You see what I'm saying? And so you want to be aware of who are you talking to, which country, how do they do their math, how do they do their decimal points, and so on. So just kind of be aware of that. Okay. Can anybody think, I think what I'll do, there's a couple more sections. There's division with decimals, which I think I'll make a little video. Has anybody tried any of it? I'll make a video of 4.5, division of decimals, and that's 4.4. 4.5 is fractions and decimals going back and forth. And 4.6 is done later. Let me take us over to, let me see, take it over to our website. Here we are. Okay. So I wanted to be sure everybody was totally clear about this. This is today. I talked about these 3 sections. This is due tonight. If you run out of time, use a late pass, but hopefully that won't be too much. We're not having class on Wednesday. I'm not here, but there are these 2 sections. And so what I'm going to do today or tomorrow is post a video that explains these 2 sections. And hopefully you'll be able from the video to do this homework. So we will have class on Friday, and also it's review. So we're trying to wrap up chapter 4, the decimals. So the plan will be this Monday, it looks like it's November 2nd, to have the second exam. And I asked people a time or two ago about did this doing the exam during class time work for them? And the only concern I think I might have is that maybe people needed a little more time to do the exam. And so there were 2 options. One would be to open up the exam a little bit before 9 o'clock, maybe a quarter of. Or another one would be to extend it a little bit after 10 o'clock, just give extra time so that people could take their time and do a proper job. That's my only thing. Somebody might not have that opportunity to stay late, or they couldn't start early. And so if that's the case with you, please let me know, okay? So, but anyway, I wanted you to see where we're headed. And so I want you to look for the video. Let's see, I'll post it here at the top of the website. And so you'll see it with a page, okay? So any more questions? I don't know, how did I finish early today? I don't know. Any more? Is there anything I can do right now? Help you?
Whoops. I wish I would have waited to do those chapters until after class.
Oh, it helps.
You made it a lot easier. I was doing it a much harder way.
Oh,
Or
okay.
just longer.
Oh, okay.
So thank you. That's
All right, let me,
that's
yeah,
a
oh,
sure
good.
benefit.
I'm glad that worked. Let me